So now that you've gotten good at Lewis structures, I want to take you back a couple slides to remind you kind of the progression we're working on here. When we talk about bonding, first we learned about sharing electrons, and now we've been able to draw these Lewis structures to show where the valence electrons are. The next piece that we're going to work on is looking at shapes, and so saying, well, you know, this explains kind of what water looks like, but we want to take our model and we want to make it even better. So we want to take our science and make it even better to explain why there's this bent shape here. And so using what we know about electrons here, we're going to be able to explain why water is bent. And that's what we do in science, right? We take a model, and if it doesn't quite work perfectly, we make it better. So we're making it better here. So we are going to be talking about shapes on this page. That's one word that we'll use. When we talk about shapes, that can be related to two different things. Electron geometry, I'm thinking like shapes, and then also molecular geometry. And when we look at water, like that model that I just had here, this is actually going to be the shape that we see in a molecule. So what I see in those actual particles is what we call molecular geometry. So just realize that those are the same thing. So this model that we're working with here is called VESPR, is how we pronounce this acronym, and it stands for Valence Shell Electron Pair Repulsion. All right. You can see that we start with a Lewis structure. You have to have that before you can work on these shapes. And if we break this acronym down, you actually kind of can understand it, I hope. So valence shell are those electrons in the outer shell, right? So the outer electrons. Electron pairs, we've been seeing lots of those, right? I've got these pairs, and then also remember everywhere you see a line, there's a pair of electrons. So electron pairs, and then repulsion. If you're repulsed by something, you want to get away from it, right? You're like, get out of here. So I'm going to be using these green bubbles, but if you can think about our electrons usually come in pairs. Instead of drawing dots, I'll be drawing more like circular regions. And these are trying to get as far away from each other as possible, okay? So they are repelling each other because, don't forget, these dots are actually negatives. And it's kind of like if you take two magnets and put them next to each other and then they push away from each other. That's what electrons do too, because like charges repel each other. So that's kind of the gist of what we're looking at here. I will be using green on this page for our electron pairs or regions of electrons. And so we want to keep an eye out for those electron groups throughout our drawings, okay? And I will also be using some little models here, and again, the greens are my big electron groups. Those electrons don't just sit in little tight lines, they actually fill up like a whole sphere of area. So this is two-dimensional, but it gives a sense of how big those electron clouds are. Another thing that we're going to be looking at when we talk about shape is we'll be talking about shape in terms of the center atoms. So I'm going to be using yellow to help us see those center atoms. You can only find the shape of one atom at a time. So for example, we'll look at beryllium and we'll look at nitrogen, and we'll talk about the shape of the electrons around that atom, okay? So as I look at this Lewis structure here, the first thing I want to think about is how many electron groups are on the center atom. And so here's how I think about electron groups. Center atom is the yellow one, and I can see that it's connected to one atom here and a second atom here. And so I would count that and say that there are two electron groups, okay? If I look down here at this nitrite ion, I again look at the yellow center atom, and now I see that it's connected out to one oxygen and a second oxygen. So notice, even though it's a double bond, I don't count it double, I just say it's connected to a second atom. And then this little pair of electrons here is also a group. So I have a region of negatives, another region of negatives, and a third region of negatives. So here I would say that I have 3 electron groups on the center. All right. So what does that look like if I kind of put a model on it here? Okay. Next up says draw and name the electron geometry. So where are those green electron clouds? So I'm going to draw this as beryllium with two big clouds of electrons. So I'm kind of drawing the model here. You can color them in if you want to sense that that electron could be anywhere in that whole region. And as you can see here, this makes kind of a line. This is as far apart from each other as those electrons can get, because that was the whole idea. They want to repel, right? So I'll go to the right and you go to the left, and let's not get anywhere near each other, okay? So this ends up being called, this geometry is called a linear geometry. And if I think about half a circle is 360 degrees, so half a circle is 180 degrees. All right, so that's what I would call my electron geometry. Next question is, how many unbonded electron pairs are on the center? So if I go back to that yellow center atom, there are no unbonded electron pairs. And it might help you to see here where there are electron pairs. This is an unbonded electron pair, so here I would say I have one. All right, so once I go from here, I can take this electron picture, and if I stick atoms onto it, it would look like this. All right, so I have my center atom, and now where these electrons are, there's an atom, a chlorine, on both sides of that. Can you see how it's still got that linear kind of shape to it? So if I redraw my Lewis structure, but I put it into the right shape now with all those atoms on it, it's gonna look like this. Sorry if you can hear mowers in the background. And this shape is also called linear, and it's 180 degrees from this point over here to this point. So here, my molecular geometry is actually the same as my electron geometry. That's not always the case, but for this particular molecule it is. So next shape that I want to show you, if I can put these away, now instead of having 2 electron groups, I have 3 electron groups, okay? And this is kind of like when you have 2 people home, you both can have a lot of space, but once a third person comes into the room or into the house, now you each have a little less space. This one's broken, so it looks a little wonky, but everyone gets a little bit less space. We're a bit more crowded now. And so if I look at my nitrogen in the middle, this is what I want to draw. Now there's 3 electron groups, and everyone gets a little bit less space. Try to get your angles roughly correct here. That'll give you, that's the whole idea with these shapes, is to do a decent job of showing what they look like. Now these angles, now I take my circle, and instead of dividing it in half, I divide it into thirds. So 360 divided by 3, I only have 120 degrees of space for each group of negative electrons. And this shape is called Trigonal Planar, which should make sense if you can kind of see the triangle there, and then it's a plane, so it's flat on the page, all right, especially if it wasn't broken. So now if I take this and I look at the Lewis structure, I can see, okay, well here's 2 oxygens, all right, so those would bond on, but then I just have this electron pair up here. So look what happens when I build this using my atoms, all right. So I take my 3 electron groups and I put atoms on 2 of them, but there's nothing here. And so since I can't see those electrons, then here's actually what I see from my molecular geometry. The 2 groups going down, and I can't see those electrons. And so when I go to draw this, my nitrite ion looks like this. Make sure you copy all those electrons over and the brackets for the charge. And so this is what I can see here. And the reason that it's bent is because there's this, I don't know, kind of looks like a ghost, little ghost of electrons up here that also want space, okay? So it's like, I get a room, you get a room, and the ghost gets a room, okay? We gotta leave space for that. And so this shape is called bent, and still, I would have about 120 degrees. It might even be a little less than 120 degrees. So as you can see here, we're gonna see a couple different scenarios when we look at these shapes. Sometimes the electron geometry matches the molecular geometry. If I have an atom on both of these, they look exactly the same. But if I have 3 electron groups and I only put atoms on 2 of them, and I leave 1 unbonded, then my molecular shape I see is gonna be different than the shape of the electrons. But you always wanna think first, center, what groups are there, and then where do I put the atoms on. So next up, we will look at a few more shapes using the same methodology.